Okay, welcome to our first category, our functional groups with single bonds, which is going to encompass three of those families. Okay, first we're going to have our alcohols here. Our alcohols, our ethers, and our amines. These are the ones we're going to focus on next. And as you can see, they each have single bond attachments to those R groups or another carbon. And so that's why I mean what I mean by single bond attachment. Okay, so this is just my way of that I'm thinking in my head that's best to, you know, organize some of these functional groups. So welcome to our first official family, the alcohols or the hydroxy mob. Okay, so they're under the benevolent ethanol empress. And so this family is known for its intoxicating influence. Okay, they're going around, they're building alliances, and they're leaving a trail of intoxication wherever they are. Okay, some functions of alcohols could be that they are substances that can dissolve other substances. That's one thing that they can do for sure. They can sterilize things. They can undergo fermentation, like in create beverages like ethanol or alcohol that we're used to. They can form hydrogen bonds. I mean, so many different things. Okay. Now, when it comes to naming alcohols, guess what? We're going to be naming them similar to how we name the hydrocarbon. The only difference is now we have our prefix, we can have our roots, but the suffix is what's going to change. And instead of having "ane" or "een" or anything like that, the suffix is now going to be "all." And so you're going to replace the last letter or the E and say, let's just give you an example. Say we have "ane," we're going to replace the last letter E with "all." And that's how we're going to basically recognize that there's alcohol added onto these organic compounds. Okay? And again, whichever carbon has the OH group is going to be specified with the smallest constituent number. So let's look at some examples here. So here we have ethanol. That means we're going to have a 2-carbon chain attached to this OH group here. And so sometimes instead of saying carbon, you'll just see an R group. And you'll see it written as ROH. That's another way to kind of write an alcohol. And again, that R group is just showing us stuff that's not reactive. Okay? So what do? We know that this is a 2-carbon. So technically it's a hydrocarbon, an alkane specifically, and that means it's ethane. But because it has an OH group, we have to drop the E and put ethanol. Same thing here. We're going to have a 1, 2, 3, 4-carbon chain that's attached to an oxygen here, and this but, which is going to be 4 carbons. And then, of course, if it's butane, it's all single carbons. We're going to take away the E and then replace it with all. So it'll be butanol. Now, when it comes to understanding these alcohols, you also want to add the location as well. So yes, you can start by saying when you're numbering, I'm going to start with my carbon number in here, 1, 2, 3, 4, because the alcohol is supposed to see this carbon. So that's how I get 1 butanol. Here, you will start the counting here, 1 and 2. That's how you would get 1 ethanol. So you just want to use these small details to help you kind of go through. Again, it's all about layering information, much like everything else we're doing in this course. We're going to say, okay, I know how to name compounds. I know how to name some hydrocarbons. Now let's kind of layer in with these functional. Remember, we do have flashcard moments. So that just means please just try to stop and then actively write something that you see on the screen. So you can have alcohol on the front, you can have some of the properties on the back, and of course, specify that it has to have that carbon OH group in order to be an alcohol. And then you can have examples of naming. I mean, you have a lot of options here, so go ahead and take them. Okay, folks? Now let's do some examples. When it comes to naming alcohol, we're still going to have our prefix, our root, and our suffix. Our suffix is going to replace any kind of E with all at the end. Okay, again, we need to make sure that we're counting our carbons based on where their oxygen is. So let's start with this first one. Here is the oxygen group. We know it's a carbon-oxygen bond, so that's good. Let's go ahead and count. 1, 2, 3, 4. That's going this way. I can also go 1, 2, 3, 4 that way. So it doesn't really matter which one you choose as your parent chain. It's going to be 1, 2, 3, and 4. So if I have that as my parent chain, that means this is a substituent. So how would I name this? I would just go with the normal rules that we're used to seeing, even in previous videos. So I'm going to go ahead and get my root. It's going to be 4 carbons, so that's going to be but. Okay. Now we know it's going to be butane because it's only single bonds. So I'll put butane. But we know because we have an alcohol attached here, an OH group, a COH group, which means an alcohol. Instead of butane, it's going to be butanol to get rid of that E. And then we also can put the location of where the alcohol is, so that's going to be 1 butanol. All right, our root and our suffix are good. Now we can go ahead and go to the prefix, which has to do with our substituents. This is 2 carbon, so ethyl group, and it's on the second carbon. So we have 2 ethyl dash 1 dash butanol. All right, let's go ahead and do this one. It is a skeletal structure, so it's a little bit different for us, right? We see our OH group. Let's go ahead and get our carbon. Because it's skeletal, you can kind of verify. Here's a carbon here, a carbon here, a carbon here. And sometimes they show you the carbon. So I'm starting off with my numbering here. 1, 2, 3, and 4. So we have another 4 carbons. But we do see that we have a double bond here. We have a double bond in this OH group. So we do have a double bond. That means we have 4 carbons, which is going to be but for our root, but we have a butene because there's a double bond here. We're going to drop the E, and we're going to get butanol. Now, what location is this? Carbon number 2. Now you're asking yourself, wait a minute, I thought we were supposed to be getting our location based on the OH group. But guess what? When you have your double bonds, you have to consolidate the double bonds as well. So we're just going to say carbon 2 is going to have the butanol. You also could say, and you'll be correct in questioning that. You're like, wait a minute, why are there 2 here? We have to consolidate the location for the actual alcohol portion, right? So we can write 2 butanol this way, meaning like we're kind of adding the location specifically where the alcohol would be. So 2-butan 1-ol. Now, of course, I'm not going to have you go have any examples like this. When you get into organic chemistry, you will have examples like this, okay? Now let's get into the ethers. The alkoxy secret society. Now, what is an alkoxy? An alkoxy is going to be a group that has an R group, which we know is going to be our unreactive carbon-carbon and carbon-hydrogen bond, attached to an oxygen, attached to another R group. Okay, so sometimes you'll just see that an alkoxy is simply just going to be oxygen attached to an R group, and they are going to be acting as a substituent. So a substituent we know is going to be ended with YL. Okay? Now, the ethers are going to be ruled by the alkoxy monarch. And this family operates in the shadows to make all the connections that these elusive oxygen bridges can create. Now, their functions are going to be numerous, just like everything else. They're going to serve as solvents. They're going to participate in anesthesia, gasoline additives, all kinds of things. Okay? Now, the most important thing is that it consists of that ROR group. So, an R group, oxygen, R group, or you can write carbon, oxygen, carbon bond. Okay? We'll just keep that in mind. Now, when we look at these examples here, which we'll see later how to name them, we see that when you're naming them here, of course, you're going to go a little bit differently in the fact that, yes, prefixes are the same, but your root and your suffix are going to combine. So your root and your suffix are going to combine to create the ending ether. So no matter what, you're going to have that at the end. So that means you have to consolidate really your substituents here. Whatever R groups are attached to the oxygen is what you're consolidating. So you're like, okay, this one it says diethyl ether because there's 2 ethers here. So that's diethyl, and the entire thing is an ether. Over here it has methylpropyl ether. Again, everything's in alphabetical order. And we'll see that example next. All right, so we have our prefix, we have our root, and our suffix that are combined to form ether. So automatically I can write ether here, and I can write ether here, because that's the ending of my name. So now that we know we have an R group, an oxygen, and an R group, all we have to do is just consolidate what the R groups are. So this is an R group here, this is an R group here. All right, this is an R group here, and this is an R group here. Now we just need to name those R groups. Here we have a methyl group, and now we have a propyl group. Here we have 3 carbons, so that's also propyl, and this is also propyl. Now let's go ahead and name it. So again, I got my ether already named down, and now I want to consolidate my substituents, and it's all going to be based in alphabetical order, just like it always has been. So we have methyl and we have propyl. The methyl, M is going to come in alphabetical order before the P. So this one is going to be called methyl, propyl, ether. Boom. Now here we have 2 propyls, a propyl here and a propyl here. So we have dipropyl. And so that means we're going to have a name of dipropyl ether. Okay? And that's it. No locations or anything like that. If you do have it, you will learn that as you get higher in organic chemistry, but it won't be for this course. Now let's get to our last group of the functional groups with single bonds. And that is the amines, or the nitrogen network. And they're led by the aminoconsigliere. Okay, this family controls the realm of nitrogen-based compounds. They can form alliances, acting as intermediates between chemical negotiations, if we're thinking of that organic mafia, okay? Some of their functions is to act as bases in reactions, build amino acids, neurotransmitters, all kinds of things, from dyes, odorants, everything. And so the goal is for us is to be able to have a little bit about maybe the function themselves, get some examples, and then be able to name them. So cool thing about amines is that you're going to name them similar to the ethers like we just saw. First, we have to consolidate, hey, what does an amine contain? How does it make them different, and why is they're their own family? Where they contain a carbon-nitrogen bond. So the bond between a carbon and a nitrogen. And as you can see, these bonds on nitrogen are open. So you can have a nitrogen bonded to a carbon, have NH2, or these hydrogens can be replaced with more carbon. So you can end up having up to 4 bonds of nitrogen bonded to carbon itself. Okay? That's like extra information. Now, one thing you want to make sure is that you know that one, you have to basically search for and find that carbon nitrogen bond, and two, when it comes to naming, the prefix, the root, and suffix are going to combine. So the prefix is going to stay the same, the root and suffix are going to combine to form amine. So if you have something like methyl, meaning you have a methyl group attached to this nitrogen here, you will write amine as your ending, and then you will have the substituent next to it. Ethyl, meaning you have 2 carbons, means that you have the substituent ethyl in front of it and amine after. So let's go ahead and get into some examples. So first things first, like every other name, you have your prefix, your root, and suffix. Here the root and suffix are combined. I'm putting it in the child. Here the root and suffix are combined to form amine. Okay? So the first thing we need to do is get our amines here. If we know that we have our nitrogen carbon bonds, I can literally write amine here. And I can also write amine here. I already have the majority of my actual name. Next, I'm going to figure out the substituents that are attached to those amines here, or that carbon nitrogen, or really I can just say the substituents that are attached to nitrogen. Okay, folks? So here we have a methyl group and we have another methyl group, so that is going to be dimethyl. Here we have a methyl group and we have an ethyl group. And so we have to go in alphabetical order. So for this one, it will be dimethylamine. Write that, dimethylamine. And over here, it'll be ethyl methylamine. And that's how you'll go about naming these.